Okay, software is installed on a computer to manage files, memory, and multitasking. State the name of the software that can do these tasks. Pause the video, give this question a go. Oh, this is really easy. Software that can do these things. Obviously going to be the operating system. Pause. Let's try that again. Pause the video, give this a go yourself first. Okay. So, different functions of the operating system apart from provides a graphical user interface. So, we could have mentioned any of the following. Peripheral management, which is basically your input and output devices like your keyboard, your mouse, etc., using things like drivers. You could have mentioned memory management. I'm just going to do man. Process management or processor management. File management. Security management. You could also mention real-time or batch processing, which I'll talk about at a later part of the video. It's not that important. You could also mention multitasking, which is a part of process management. You could also mention interrupt handling or handling interrupts, which is also, you could argue, a part of process management. You could also mention managing user accounts, which you could argue is a part of security management. You could also mention running software, like application software. Okay, pause the video, give this question a go yourself first, and then I'll go over the answers with you. Okay, so what we have is 5 different jobs of the operating system. What do they do? Interrupts. So we're looking for signal, we're looking for handler. There we go. A signal that causes the operating system to take a specific action. Utility. So utility software, utility programs which perform a specific job. That's what utility software is. Disk defragmenter does a specific job. Disk cleaner does a specific job. Memory management, so we look at all managing memory, RAM, virtual memory, anything to do with that. Anything to do, okay, so blocks of memory. Spooling, something that talks about buffer. So just quickly go over spooling. If I'm printing out something, let's say 500 pages for my PC, I'm sending it to a printer, what it will do is it'll put all that data into this like little memory in the printer called a buffer. This will have like 300 of the pages. It'll then start printing out. So this is like 300 pages of the 500. When it starts printing, it'll empty out the buffer, and then it'll ask for the next 200 pages which are remaining. It'll go into the buffer, it'll print all of these out, and it'll see if there's anything more. The reason why it's got a little bit of buffer here is because it stops the printer from having to say, yo, give me another page every time it prints out something to the PC. The PC gives it like 300 pages, it deals with it, and then it asks for more. Instead of the printer saying, hey PC, I printed out a page, give me the next piece of data. Hey PC, I printed out this page, give me the next piece of data. It'll get annoying. So that is what spooling is. And then finally, we've got multitasking, which is the ability where it appears that you've got many processes which are running at the same time. But we know that is fictional, it just feels like that. Okay, so now we're going to be branching over into software. Give two types of system software. Pause the video, give it a go yourself first. Okay, so there are two different types of system software. You've got the operating system and you've got utility software. There are your two types of system software. Pause the video, give this question a go yourself first, and then I'll go over it with you. Let me just make it a bit bigger. Okay. So I'm hoping you can give this a go yourself first. Let's do it. Something software provides the services that computers require, like utility software. So you've got utility software. What did I say was above that? It's system software. So system software, and this is a good definition, provides services that the computer requires. So utility software provides services. The OS provides services, like multitasking, etc. Something software is run on the operating system. So what is actually ran though on the operating system? Well, you've got the operating system. You've got hardware like your keyboard, your RAM. So if I was to click on an app, or an icon should I say, using my, let's say, mouse. So I click on an icon, let's say it was Valorant, double click. I'll find it. My operating system deals with everything. It then runs Valorant, which is a type of application. So an application is run on operating systems. Without the operating system, we won't be able to run these applications. If we didn't have an OS and we tried to run Valorant, we would need to know machine code to get all of this running. So the question or the gap is something software is run on the operating system. And that'll be application software. So we've done application software, we've done system software. The something is run on firmware. Okay, so we haven't really talked too much about firmware before. So let's quickly talk about firmware. Firmware is special code. It's software. Well, special code is software, so it's special software. And what's its role? Its role is to control how PCs, phones, game consoles load up. Is that familiar? Well, it should be, because basically firmware is what we have another name for it, and that's the BIOS. And the BIOS lives in a ROM. So, think this through for a second. Let's take this right back. We turn on our PC. So you hit the power button. In the PC, you've got ROM, RAM, and SSD. The first thing which gets engaged is the ROM. The ROM has BIOS, which is also known as firmware. What that'll do is it'll load up our computer successfully, but how? Well, what lives on the ROM, remember it's non-volatile, is also our operating system. So the operating system kicks in. So the BIOS, i.e. the firmware, is code which loads up our computer, which also loads up our OS, so that we can start using Microsoft Windows, for example. So operating systems live on the ROM. Once we start using the operating system, it moves then parts of it into the RAM, because we're using it. So the something system is run on firmware. That would be the OS. The firmware is run on the what? Well, we know it's run on ROM. And ROM is a type of hardware. And there you go. So, system software provides services that computer requires, like utility software, also is the OS. Application software, so apps run on the OS. That's what we use an OS for, to run application software. The operating system is run on firmware because it lives in our boot ROM. The bootstrap, the BIOS, the firmware loads up the OS. The firmware, the BIOS, lives on hardware such as the ROM. Which type of software runs directly on the OS? Pause the video, give us a question. Give us a question? Give us a go. Well, we just established this in the previous question. You've got the OS, you've got firmware, which lives on the hardware, such as the ROM, and the OS runs application software. The below is a question about utility software. We haven't covered hard disk formatter, that's A level, but I'm going to talk about this anyway, just in case. However, you should be able to do this question here. Pause the video, give it a go yourself first. Okay, so how does hard disk defragmentor work? Well, this is your hard drive, this is your different sectors. You might have like Valorant here, you might have Valorant here, you might have Roblox here, you might have Valorant here, which means that Valorant, the different files, are separated from each other. What a defragmentor will do, it will reorganize your hard drive sectors, which brings together files, data, which is split, which will improve performance of your computer. Why? Because it doesn't need to go out searching for different files in different sectors if it knows that all the files are next to each other. Speeds it all up. Disk deformatter. Disk formatter is an A-level concept, but we're doing a new syllabus and we could very well pop up. Who knows? So I'm just going to go over this quickly anyway. So we use this when we want to get our hard drive, or SSD or HDD, set up for the first time, or if I want to wipe everything clean and start again. So if I want to start again on my PC, I can use this software called Disk Formatter. And what it does, we can say it prepares it for initial use. It puts into our disk sections. So let's say our HDD, it creates the different sections on it. It sets up our file system. So it organizes all our data. So if I go to here, this is like all my files here, it organizes that for the first, remember we're doing this for the first time. So it sets things up ready to be used. So prepares for initial use. That's key for the first time usage. It would also check for errors. So let me explain. Let's imagine that my computer's becoming really slow. I've got loads of files. I just want to start all over again. Reformat my hard drive. The first thing it will do is it will scan my current hard drive and look for any errors. Because before it basically can clean it all, it needs to fix the errors. Once it fixes the errors, so it finds an error here. Let's imagine it's like a file I thought I deleted, but I didn't delete it properly. It'll remove it for me. It will then clear out all of my data, so it'll all go. So it'll wipe it all clean. So there's my hard drive now, and then it'll recreate the different partitions for different sections. It'll then put in place the different files I need and organize it. Okay, so now let's go into tasks of the operating system in more detail. The first one, give one task that the software allows the user to do to manage files. Let's talk about VOS. Pause the video, give it a go. Okay, so what do we mean by file management? That's basically what it's saying. Give an example of what we can do. Well, in file management, you can do any of the following. Let me just move this up. Okay, you can create a file. You can delete a file. You can rename a file. You can also do things like open a file, close a file. You can delete, we actually said delete already, move a file to a different folder. You can sort them out in order, like alphabetical order. You can save a file, create a file. So any of these are jobs that you can do in file management. You could also do permissions, like read, write, access. Okay, pause the video, give this question a go first yourself. Alright, I'm going to go through and basically kind of reteach this. You've got your CPU, you've got your RAM, you've got your hard drive or SSD, which has virtual memory area on it. Okay, so we're going to talk about how this actually works. A couple of things. Number one, we know that RAM is split with your address, location, and then the data and instruction. But I'm not going to talk about things in general terms. I'm going to be quite specific now. What we need is VOS as well to be a part of this equation. VOS needs to know what status or availability there is in a RAM. So that's one thing in terms of memory management VOS would do. So let's imagine this is full, this has got something in it, this is empty, this has got something in it. VOS is responsible for tracking the status of each memory location, but not just that it's full, but also what processes are being executed by the CPU. Okay, so the OS needs to be aware, I know it's address number 1, which is currently in the CPU, and it's data. So it's being fetched, occurred, and executed. So it's what's available, and also what's happening to that process. So part of this is VOS has to track the movement between, so it tracks the movement between RAM and the CPU, but not just between the RAM and the CPU. It also has to track the movement between the RAM and the virtual memory. So remember, when RAM becomes full, data is then moved into the virtual memory. So I'm going to put and RAM and VM. the operating system, so let's imagine right now that we've got, I'm just going to clear this out slightly to make this a little bit wider. So you've got RAM. Made that a little bit too big, but whatever. Address 1, address 2, address 3, 4, 5. And let's imagine that we've got Valorant loading screen. This is also part of the Valorant loading screen. It's quite a big amount of processors for the loading screen. We've got another bit of Valorant loading screen. So that could be like the music part. We've got Spotify open. And Spotify again, because Spotify is going to be made up of lots of different processors. I'm currently playing Valorant, so this is going to be needed, this is going to be needed, this is going to be needed. The problem is, the loading screen needs one more space in the RAM. Because remember, it's quite a big beast. So the operating system needs to be able to recognize, uh-oh, we need more space in the RAM for the Valorant loading screen. We've currently got 1, 2, 3, but we need 4. So the OS, part of memory management, checks that the processors have enough memory located to them, or have been allocated enough memory in the RAM. Then it recognizes I'm not using Spotify. I'm playing Valorant. Spotify is in my background. It's open, but I'm not really using it. What's it going to do? Well, it's going to take the Spotify and move it into my virtual memory. That's not my virtual memory, that's my virtual memory. And it's going to put the Valorant loading screen into here. So we call these processors, so like Valorant loading screen, Spotify, song select, you know, so one game is made up of hundreds of thousands of different processors. These processors are called pages. Keeping it really simple at the moment. So the OS is responsible for moving this called transfer. For transferring pages between virtual memory and the RAM. So we've got memory management. Operating system is responsible for tracking the status of each address location. So what's available, what's not available, where Valorant is at the moment, the loading screen, is it being part of a CPU, is it being executed. It also keeps track of the movement between the RAM and the CPU and the RAM and the virtual memory. It checks to see that each process has enough space in the memory. And it's responsible for moving things from the RAM to the virtual memory, call that transferring, of these processes called pages. So when RAM becomes full, certain processes, certain pages are sacrificed and put into the virtual memory so we can make space for things we're using. By doing all of this, it allows us to do multitasking, because it doesn't close things off. It doesn't close Spotify. It allows us to use Spotify again later if we need it. So it allows us to, and the CPU to, basically fetch different processes. Remember, it feels like it's at the same time, but it's just rapid because the operating system tracks everything. By the operating system tracking things and knowing where everything is, it allows the CPU to fetch, decode, execute lots of different processes rapidly. If I am listening to Spotify and playing Valorant at the same time, it would basically CPU, Valorant, Spotify. The CPU will start there, then it'll go to there, then it'll go back to that again and fetch Valorant and fetch Spotify, and it'll do it rapidly in milliseconds without us really noticing. But it'll be the operating system which manages everything and tracks everything for that to happen. Okay, so pause the video, give this question a go yourself first. I'll go through the question and solution and understanding. Okay, so I'm hoping you give this a go yourself first. So memory management, this is basically talking about an aspect of memory management when we're using the virtual memory. Remember, memory management isn't just using virtual memory, it's also about tracking things from the CPU to the RAM, what's being used, what's not being used, etc. What we saw in the previous video. So in this situation, it's asking us how is virtual memory created and how is it used. Well, we've got our RAM, we've got our hard drive. So what happens is the hard drive is partitioned. That means it's got a section on it, which is going to be virtual memory. If you didn't use the word partitioned, that's fine, but for now, from this point forward, use that word partitioned. It separates it, so the hard drive is split, where we've got some virtual memory allocated to it as well. When RAM is full, the pages, remember that word, pages, from the previous question, which are not used or needed, are transferred from the RAM, that was meant to go to the virtual memory, transferred from the RAM to the virtual memory. When it's needed again, so when that page is needed, that process is needed, it'll be taken back from the virtual memory back into the RAM. So let's put that into an answer. HDD is partitioned to create virtual memory. When RAM is full, pages not required, so processors which are not required or not needed or not being used are transferred. So each point I'm putting is a mark here. Transferred to the virtual memory when page or process or data is needed again. It transfers. My hand is killing me, I don't know why. Okay, so it transfers from virtual memory to RAM. There you go. Nice and easy. Okay, so pause the video, give this question a go yourself first. I'll go through the question and solution and understanding. Okay, so I'm hoping you give this a go yourself first. So memory management, this is basically talking about an aspect of memory management when we're using the virtual memory. Remember, memory management isn't just using virtual memory, it's also about tracking things from the CPU to the RAM, what's being used, what's not being used, etc. What we saw in the previous video. So in this situation, it's asking us how is virtual memory created and how is it used. Well, we've got our RAM, we've got our hard drive. So what happens is the hard drive is partitioned. That means it's got a section on it, which is going to be virtual memory. If you didn't use the word partitioned, that's fine, but for now, from this point forward, use that word partitioned. It separates it, so the hard drive is split, where we've got some virtual memory allocated to it as well. When RAM is full, the pages, remember that word, pages, from the previous question, which are not used or needed, are transferred from the RAM, that was meant to go to the virtual memory, transferred from the RAM to the virtual memory. When it's needed again, so when that page is needed, that process is needed, it'll be taken back from the virtual memory back into the RAM. So let's put that into an answer. HDD is partitioned to create virtual memory. When RAM is full, pages not required, So processors which are not required or not needed or not being used are transferred. So each point I'm putting is a mark here. Transferred to virtual memory when page or process or data is needed. Again, it transfers. My hand is killing me, I don't know why. Okay, so it transfers from virtual memory to RAM. There you go. Nice and easy. Okay, so this is another question. It is slightly harder than the previous question, but it's using the same knowledge. Explain how virtual memory can be used in this scenario. So pause the video, give the question a go. Boom. Computer pages A, B, C stored in RAM. So we've got RAM, and we've got A, B, C, which is in RAM. Page D needs to be sent to the RAM, but the RAM is full. Page B is not needed immediately, so what happens? Well, same again. Hard drive, partitioned to create virtual memory. Boom, just partitioned it. 2. Page B transferred to virtual memory. Boom, done it. Page D transfer to new free space in RAM. Boom, done. Once A, B, C is not needed, B can be sent back to RAM from virtual memory when needed. So you've got B here, D is no longer in the hard drive, it's here. Let's imagine that D's done its job. We need to use B again. D could be switched out. And B's back in here. So it's lots of switching. Pause the video, give this question a go. This should be really straightforward now based on the previous questions we've just did. Okay, so what you should have is RAM. What you should have is your hard disk drive. What you should have done is partitioned it into virtual memory, and I'm going to put little arrow going partition just to be geeky. And the final thing what we need to do is we need an arrow going both ways, because it can go both ways between virtual memory and RAM. I'm going to put transfer pages. So you get a mark for that, you get a mark for that, you get a mark for that, and you get a mark for that. Pause the video, give this question a go. Okay, before we begin, 3D modeling, what is it? 3D modeling is the ability for developers, designers to basically recreate real life objects from a 3D perspective. This is as basic as it goes where my mouse is right now. So like in video games or movies, you start off with using shapes like this, but you make it really, really complicated to the point that it looks like it's real. You can imagine our school laptops not being able to handle something like this, especially if we're doing top-end 3D modeling. So let's go back to the question. Why is virtual memory going to be needed for this? Well, if we didn't have virtual memory, RAM is very limited. You can imagine that 3D modeling is going to take up a lot of our RAM and more. If that is the case, what happens when a RAM becomes full to our computer performance? It starts slowing down, it crashes, etc. So, by us using virtual memory, what we're doing is we're expanding our RAM. it's kind of making more RAM, but it's not, because we're using virtual memory, but it's kind of like doing that. So it's to prevent the slowing, the crashing, the freezing. It will be slow, so I'm going to keep slow there, but it prevents crashing, it prevents the freezing. It allows us to process the large amounts of data which 3D modeling is going to require. So, number one, it extends the RAM, makes it bigger. Prevents, now I'm going to use, for concept here, 3D modeling software to freeze. It prevents it freezing, crashing. And it allows our PC or computer to process the large amounts of data needed for 3D modeling. So you notice how I'm talking about 3D modeling constantly. I keep referring back to the scenario they gave us. If it was about high-end video games, I'll be linking it into high-end video games. But for this, it's 3D modeling. So it extends the RAM. It basically makes the RAM bigger, in essence. It prevents freezing and crashing. Yes, it slows down our computer slightly, but it prevents it freezing and crashing completely. It allows our PC to handle the large amounts of data which is needed for us to do 3D modeling in itself. Okay. So here we go. We've got a question which looks at process management and provides a user interface for the user. Pause the video, give it a go yourself first. Okay, let's deal with process management first. So what you've got to remember is that these processes or pages, let's say process 1, process 2, process 3, they're waiting in line to see the CPU to be executed. That doesn't sound pleasant. And what we do is we follow a schedule. They're given a priority, so this could be the highest priority, which means that this dude will get seen first, even though they're in line. But if they have the same priority, they'll just go 1, 2, 3. So process management allows the OS to manage the scheduling, the schedule of processes being executed or processed. Now, it handles the priorities, if there are any, but it makes sure that if there's no priorities, everyone gets the same amount of time. So this might get 30 seconds, 30 seconds, 30 seconds. This dude's like, yo, I'm not done yet. You still haven't finished doing like the loading screen. It'll go back to this one, this one, this one. So it'll keep looping until it's done. When it's done, goodbye. So it makes sure that everyone has equal time for processes. Spelled wrong. So it allows equal time for the processors. And remember what we said about the CPU. The CPU does multitasking. Remember, it's not really at the same time. It's not simultaneous, but it feels like it. So it allows multitasking. It allows us to go from this one to 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 this one, blah, 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 blah. So that is process management in a nutshell. When we talk about user interface, remember what we said about the OS. We've got the OS, we've got hardware, we've got application software. So it allows users to communicate, that means comms, with hardware. So it allows me, when I'm using the operating system, to talk to the RAM, to load up things without really knowing what I'm doing. I just double click on an icon to load up a game. It launches it, but I don't need to have any machine code knowledge. Users interface or GUI to make it easy for user. And I'm going to give you one last thing. Provides ability for user input. Think about it. If I'm right now on my keyboard pressing that, I've just inputted something into my keyboard, into the computer, and output. So when I press the start key, how do I know it worked? It worked because I can see my start menu. That's the output. It's displaying the result of what I've just done. When I'm pressing this pen down on my stylus, I'm doing this. How do I see it's working? Because I can see an output. The input is me doing something with my pen. The output is what I see. So these are process management and user interface management. Allows multitasking, equal time for processes, handles priorities, but the main thing is it allows scheduling for the processes to be processed. Interface allows users to communicate with the hardware, makes users the interface to make it easy, provides ability for user input and output. So let's begin this with a nice question. What is meant by an interrupt? I'm going to make this 2 marks. Pause the video, give it a go yourself first. Okay, so an interrupt is a signal. That's vital. It's a signal. It's a signal to the operating system, so it allows the OS to take a specific action. So for example, if I am running a game and there's an error in the code and the game crashes, it will send a signal to my OS to say it's crashed. My OS will then display a message saying, game crashed, would you like to send a report? Blah, 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 blah. It could also be, I'm playing a game, but before I'm playing a game, I want to print out, let's say, 300 pages worth of work. I start playing my game, all of a sudden there's no more pages left in the printer, so it's run out of paper. So it's going to interrupt my game, and a message will pop up saying, printer ran out, would you like to replace the paper? So it'll send a signal, and it interrupts my game, but that signal goes to my OS. My OS is like, okay, let's quickly display this message. Alright, pause the video, give this question a go yourself first, then let's go over the answer. Okay, interrupts can be hardware or software. True. It could be like your printer running out of ink. It could be that your software has crashed. Interrupts are handled by the operating system. True. Interrupts are handled by OS. Interrupts allow a computer to multitask. Yes, because if we're doing something, so you've got your CPU, you've got a game, you've got your printer, for example. Interrupts occurs, interrupts signal goes to there. This then says to CPU, the printer needs your attention, so it goes from the game to the printer. So it multitasks, it can do multiple things simultaneously. Interrupts allow or work out which program to give priority to no. Even though the printer running out of paper is important, it's the OS who makes the decision about priorities, not the interrupt. Interrupts are vital to a computer and it cannot function without them. True. Without interrupts, you can't multitask. Without multitasking, you can't perform lots of operations like we do today. Alright, pause the video, give this question a go yourself first, then let's go over the answer. Okay, interrupts can be hardware or software. True. It could be like your printer running out of ink. It could be that your software has crashed. Interrupts are handled by the operating system. True. Interrupts are handled by OS. Interrupts allow a computer to multitask. Yes, because if we're doing something, so you've got your CPU, you've got a game, you've got your printer, for example. Interrupts occurs, interrupts signal goes to there. This then says to CPU, the printer needs your attention, so it goes from the game to the printer. So it multitasks, it can do multiple things simultaneously. Interrupts allow or work out which program to give priority to no. Even though the printer running out of paper is important, it's the OS who makes the decision about priorities, not the interrupt. Interrupts are vital to a computer and it cannot function without them. True. Without interrupts, you can't multitask. Without multitasking, you can't perform lots of operations like we do today. Okay, pause the video, give this question a go. I'll go through a solution like normal. Alright, so this question is asking you basically how do interrupts work. And it's giving us a scenario, someone's reading a text message on a phone and they get a telephone call. How does that happen? Well, we should kind of know this already. Step one. The interrupt signal is sent to the OS. So if there's an interrupt signal, it goes to the operating system that there's a phone call. The CPU will stop the task they are doing, they are processing. So it'll do like a halt. So if we've got the CPU, it's currently doing like WhatsApp, so text messaging, a phone call comes in. The CPU now has to deal with the interrupt. So CPU deals with or processes the interrupt. The CPU, to do this, uses what is called the interrupt service routine. So then what happens is data in CPU is stored in memory, so it's not lost. The user will get notification of call. After call, like the phone call by the way, data in memory, like the text message, like WhatsApp, goes back to CPU. So it's simply, if I go back to the diagram form, CPU is WhatsApp dealing with like a text message, phone call comes in, the OS handles it, it tells the CPU to stop, the CPU will then move WhatsApp into memory, it allows the user to do the phone call. Once the phone call's up, WhatsApp goes back into the CPU. The CPU has to deal with the interrupt, which is the phone call, and it uses what's called an interrupt service routine to do that. The interrupt signal, remember, is sent to the OS first. Pause the video, give this a go first yourself. Okay, so give 2 examples of when an interrupt would be generated. So we know that you've got your hardware interrupt, and we know you've got like software interrupts. And the way I would answer this is to give an example of both of those. Now, a software interrupt could be like we had in the previous question, the phone call coming in onto a phone. So it could be like changing a task. So you could have mentioned like using, so I would actually do software interrupt. So I write the word software interrupt and then give an example, such as user using a social media app gets a notification from another app That could be an example of a software interrupt. It could be something along the lines of the phone call one. That's an easy example. It could be another situation, so anything which is basically changing a task from one thing to another. Or it could be user playing game, error in code, game crashes with an error message. That's another type of interrupt. Another one which we haven't talked about is dividing by 0. So let's imagine that you're using an app and the app is trying to do a calculation, and for some reason it's trying to divide by 0. As you know, in maths, you cannot do that. And what happens is, if you try and divide by 0 on a computer in code, it will crash, creating a software interrupt. So an example, I actually did this for one of my apps where it tried to work out a percentage score for a student. So normally you would take the student score, which is like 8 out of 10, 8 divided by 10 multiplied by 100. But this student didn't do the test. They're still in the database, so they had 0 divided by 10 times 100. The problem is you can't do that. So it crashed because they weren't here for the test. It still tried to calculate them, their percentage. So it created a divide by 0 error, which is a part of the software interrupt. You could talk about hardware interrupts, such as the easy one is the printer running out of paper. So you can write hardware interrupt here. Printer running out of paper. You could also do, let's say, phone battery dying. And the final one, which we can talk about, is you've got RAM, address 1, address 2, address 3, address 4. And you've got two processors, 2 pages, trying to go into the same address location at the same time. For some reason, the OS does that. That will create an interrupt. So software interrupt example, a hardware interrupt example, you can talk about any of these. Accessing the same memory location for a process or for processors. You can talk about dividing by 0 as an error. You can talk about printer running out of paper. You can talk about crashing in games. You can talk about using social media and getting a notification on something else. If the question was what can cause an interrupt, you could also talk about, this isn't doing that, but you can talk about things like using a keyboard. You can talk about using like a mouse. You could talk about error in code. So these are all direct causes. These are more examples of interrupt. Cause, example. Cause, example. So your peripherals, input-output devices is a big one.